In lesson 11.6, we are going to talk about some counting principles. Counting principles are the ways to count things. I mean, that's essentially what it is. The reason we use this is when we get into probability. Unfortunately, we're not going to make it to the probability lesson, but we are going to talk about counting principles. So the reason it's so important to be able to count things is because if we want to know the probability of something happening, we need to know the total number of ways it could happen. Okay. So a lot of this will be familiar to you from Algebra 2 and even from geometry. You did some of this. So let's start. Well, let's just jump in with these. Sometimes we can just count them. Okay. It's very simple to do. These first couple examples are like that. So we have 8 pieces of paper that are numbered 1 to 8. You draw one piece out, write down the number, put it back, and then you draw a second piece of paper, write it down, and we're going to add the numbers. How many different ways can we obtain a sum of 12? So we just have to think of different ways to get 12. So you could get a 4 and then get an 8, or you could get 8 and then a 4. You could get a 5 and then a 3, or not a 3, a 5 and then a 7, and a 7 and a 5. Or you could get a 6 and a 6. So it looks like there are 5 ways. All right, the next question, same process, but this time we do not replace the paper. So we draw one out, we keep it, and then we draw out another one. How many different ways can we get the sum of 12? Well, it's the same question, except we can't do this one because if we take the 6 out and keep it, there's not another 6 in the box. So now there's only 4 ways for this to happen. Okay, and again, the reason we would want to know this is if we were calculating some sort of probability, if this is some sort of carnival game, we would want to know the total number of ways something could happen. So that leads us to the fundamental counting principle. If you have 2 different events happening, if the first event can occur m1 different ways, and then if the second event can occur m2 different ways, the total number of ways the 2 events can occur is m1 times m2. Kind of the classic problems that you'll remember from this is like, let's say you're going to Eric's to get an ice cream cone and they have 10 different flavors of ice cream and 12 different toppings, and 3 different types of cones. Like, so how many, 1 scoop cones with a topping can you order? And you just multiply 10 times 12 times 3. Okay. So we'll do a little bit more complicated problems with this. But we have a combination lock, like the ones that used to be on your locker. You have to get the right choice of 3 numbers from 1 to 30. How many different combinations are possible? So we need to think about the 3. We have 3 situations. We have 3 numbers here, okay? Those are our 3 different events. So the total number of ways that we can pick that first number is 30. The total number of ways we can pick the second number is 30. And the third number also 30. So we just multiply those and we get 27,000 different lock combinations that are possible. So telephone numbers, this is actually a really practical example. Telephone numbers in the US, the first 3 are the area code. How many different telephone numbers are possible within each area code? Okay, so let's just focus on our area code, so 419. We want to know how many different possibilities for phone numbers are there if the first digits are already set. Okay, so this we're going to ignore. So we have 7 digits left to fill. Now, this first digit cannot be 0 or 1, so we only have 8 other options, 2, 3, 4, 5, 6, 7, 8, 9. Now for the next number, it can be anything. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. So we have 10 options here, and 10 here, okay, all the way down. So the total number of area codes in the 419 area code are 6 zeros. So we can have 8 million area codes, or phone numbers within an area code, which seems like enough, I would think. Now, These things change if for some reason you're not allowed to repeat numbers, okay? So we'll see some more examples of that a little bit later on.